Okay, so now the next cycle that we need to talk about from glycolysis, and remember that was creating or generating the pyruvic or pyruvate that we need. So this is the Krebs cycle, and what enters into the Krebs cycle, of course, is one molecule of pyruvate. All right, so one molecule of pyruvate enters in. And there's going to be some chemical rearranging here. We're going to have oxaloacetate, which is going to be on this side coming into the cycle. And I kind of think of the oxaloacetate as like starter material. And then, of course, oxidizing the pyruvate. CO2 will be given off here. Oops. Sorry. All right, so CO2 is given off here. As the pyruvate and the oxaloacetate kind of create this acetyl coenzyme A complex. And then we have our citric acid right here. Now, this follows your clock phase pretty well. Just make sure that we have this brand new electron carrier that may have been left off initially. Okay, so citric acid is going to be further oxidized. We see CO2 given off. And then, of course, we're going to have some hydrogens free and some electrons. And so that's where our NADH comes in, of course, plus an H+. And then as the carbons are given off as well as the hydrogens, that's going to leave us with a 5-carbon compound called succinate. And I'm probably saying that wrong. Please don't judge me too harshly. But the succinate is then going to be converted into a 4-carbon compound, and we said that this was oxaloacetate, and I'm not quite sure I spelled that one correct either. But as the succinate is being oxidized, you see CO2 being given off, as well as the production of these hydrogens. But don't worry, these electron carriers, the NADH, is going to be there, as well as this new guy called FADH2. They're going to be picking up those electrons that are coming from the hydrogens as the compounds are being oxidized. And then we have the oxaloacetate being that starter material for the second pyruvic acid molecule to form the complex acetyl-CoA. CO2 is given off, citric acid, CO2, NADH, succinate. And, of course, you can see a trend here. These names may help you. It doesn't help me because it helps me think about them as being like people and where they need to be in the cycle. Down here at the bottom, we have it kind of broken down. So if you're looking at single cycle, it says 2 carbon dioxides, but I'm going to go ahead and say 3 because as pyruvate and oxaloacetate are coming together to form this complex, we see CO2 being given off to form that 6-carbon compound called citric acid. We have 1 molecule of ATP. This is kind of the star of the show right now. So 1 molecule of ATP, and then 1 FADH, and then your 3 NADHs plus your 3 hydrogens. So, but then of course, if you have your 2 cycles for every 2 pyruvate molecules, so you just double your numbers. Okay, in a sense. But this is the Krebs cycle. And remember that pyruvate, also called pyruvic acid, is coming from glycolysis. Okay, so let's take a minute and let's kind of recap how much do we have so far. All right, so glycolysis produces 2 ATP, 2 NADHs, and 2 pyruvates. The Krebs cycle, or also called the citric acid cycle, is going to give us 2 ATP. Let's see, I think we've got 3 NADHs. And of course, plus the H+. And then 1 FADH2 and 3, and I'm going to go ahead and say 3, but 2 to 3 molecules of CO2. All right, so for the next one, we're going to look at an animation of the electron transport chain.